Hi, you're welcome back to my YouTube channel. It's been quite some time, but I'm back again. Are you yet to subscribe? Please do so. And for my returning subscribers, I appreciate you. I always do. So today is going to be on chemistry. We are still in separation of mixtures, and today we round it up. But before then, let's get started.
Over the horizon, over the horizon.
Welcome back. So we've discussed the last 12 methods of separating mixtures, and today we are going to finalize it up by discussing the remaining 3 methods of separating mixtures. So the first is the fractional distillation. The first for today, which I will say is the 13th, is the fractional distillation. Now, this method is used to separate 2 or more mixable liquids with different boiling points, and this is what distinguishes it from ordinary distillation, which is used to separate only 2 mixable liquids, but that cannot be used to separate 2 or more mixable liquids, and that is why we have to introduce fractional distillation to be able to separate 2 or more mixable liquids. Okay, so on the apparatus for this fractional distillation is basically the same with that of the ordinary distillation, except that in fractional distillation a fractionating column is introduced between the distillation flask and the condenser. That is just the difference. The ordinary distillation does not have the fractionating column, but this fractional distillation has the fractionating column, and it's in this fractionating column that the main process of separating the mixtures occur. Now, this fractionating column is packed with glass beads, and that is what does the actual separation. The upper column has a lower temperature than the lower column. And for a vapor to be able to distill over into the condenser, it must have the same temperature with that of the upper volume. So that is vapors with lower temperature will now distill over first, because they will have the same, because since temperature on that upper volume is lower, the vapors with the lower temperature, whose temperature rhyme with that of that at the upper column, will now distill over and be collected at the conical flask. They distill into the condenser and then will be collected at the conical flask. Now, those with the higher temperature, when they rise up, when the vapor will rise up to be collected over, it will be condensed and falls back into the mixture because the temperature is higher than that at the upper column. Now, when all the vapors with the lower temperature has finished distilling over, the temperature now rises at the upper column, and then the process starts all over again for the vapors with the higher higher boiling point, whose temperatures will now rhyme with that at the upper column before they can now be distilled over. That is how it is done in the lab. That's how it is separated in the lab. However, in the industry, it is separated in higher. You cannot use that method in the industry because there it requires a larger amount, larger quantity. Crude oil, petroleum. That crude oil is the same thing as petroleum. This contain many natural products that can be recovered from it. Many natural products can be recovered from crude oil, petroleum, like they include products like petrol, kerosene, natural gas, diesel, lubricating oil, bitumen or pitch. These are natural products that can be recovered from petroleum or crude oil, and for that to happen, fractional distillation must occur. They can be recovered through fractional distillation. That is the only method that can be used to recover this. And this fractional distillation plant in the industry is made up of two main parts. The boiler, this is where the crude oil is kept boiling. The crude oil is kept boiling there, and then fractionating tower where the actual separation occurs. The boiler and the fractionating column. The boiler where the crude oil is kept boiling, and the fractionated column is where the actual separation occurs. Fractions with lower boiling point will distill over at the bottom of the fractionating column, while as the mixture rises up, they just keep distilling. Once each vapor reaches its own boiling point, it will distill over. So those with lower boiling points will distill first, while those with higher boiling points will distill over later as the mixture rises. And that is actually the process of fractional distillation in the process of fractional distillation, both in the industry and it's also in the lab and in the industry. So you can say that it is used to recover natural products like petrol and kerosene, natural gas, etc. Yeah, all these petroleum products, they are recovered from fractional distillation. The next method is the separation. However, before the fractional distillation, you can see the diagrammatic representation. The fractional distillation. This is the apparatus used to separate the mixtures. Like I told you in the lecture, this apparatus is basically the same with that of the ordinary distillation, except for this. This is the fractionating column, which differentiates the apparatus for the fractional distillation for that of the distillation. And this is where the main process takes place in this fractional distillation. Now this is the upper part of that column, where the temperature must rhyme with the vapor coming up from the mixture. That the temperature here is lower than the temperature that is down here. The temperature here is lower. So the vapor with the lower boiling point must rhyme with the temperature here before it can distill over into the condenser and then will be collected. So this is, you can see that we have two conical flasks here. The first is the first fraction of the distillate that has been collected, those with the lower boiling point, and this is the second fraction of the distillate, those with the higher boiling point. So like I said, those with the lower boiling point will distill over first. When they are through, the temperature here now rises in order to accommodate the vapor with a higher boiling point, whose temperature must rhyme with that of here before they are now collected into the second flask. So this is where it is seated. This is the round bottom flask containing the mixture. Fractionating column. This is thermometer which is used to gauge the temperature of here. And then this is the water inlet. This is the water outlet which cools the condenser, and that is it. So this is the apparatus for fractional distillation. Okay. The next is the separating funnel method. This separating funnel method is used to make a mixture of polar and non-polar solvents like kerosene and water. The polar solvent there is the kerosene, is the water, while the non-polar solvent there is the kerosene or the petrol. So let's say petrol and water. Petrol and water. These two can never mix together. No matter what you do, they can never ever mix together because they are polar and they're non-polar. So the process of separation involves the lower, denser liquid layer is now tapped off when the separating funnel is introduced and the mixture is poured. The lower denser liquid, the layer of the lower denser liquid is now tapped off, leaving the other layer behind and and that is how the mixture is separated. And then the last but not the least is the chromatography. The chromatography, this is the last but definitely not the least. Now this method uses a solvent moving a porous adsorbent medium like paper or gel to separate a mixture of solids. So this chromatography has many types of they are of many types anyway, and they are widely used in separating colored as well as non-colored substances, colored as well as non-colored complex substances like amino acid, dye, ink. Yeah. Now, however, the commonest method, which is the ascending paper chromatography, it makes use of a strip of chromatographic or filter paper. Now, the solution containing the mixture of solutes to be separated is spotted onto the strips. It is spotted onto the strips near one end. The paper is now removed and placed in a tightly covered jar with the spotted end, not the spot where the mixture has been spotted, not the spot, the spotted, with the spotted end dipping into an appropriate solvent. Now the solvent now moves up the paper strip. The different solutes in the mixture also move along with the solvent at different speeds. They move along at different speeds, and as they move along, they become separated because of that different speed that they move along. They now start distinguishing themselves from each other because they are not moving at the same speed. The paper strip is now removed from that jar when the solvent has moved about 3/4 of the strip. It has moved out 3/4 way up the strip. It has moved up, then it is dried, and if necessary, it's sprayed with the appropriate chemical reagents to locate the positions of the various solutes along the strip. This is very necessary in order to locate the positions of the various solutes along the strip. That spray helps to be able to locate them more. Now, each solute can now be identified by the distance it has moved. Okay, this is done by comparing its distance with those of the known standard solutions, that's known standard substances. The rate at which the different solutes move up the paper is determined by two processes. The first process is the adsorption of the solutes by the paper, and the second is the dissolution of the solutes in the solvent. These are the two main methods. The two main methods which determines the rate at which the different solutes move up the paper strip. Now, as the solvent ascends the paper, it dissolves the mixture of solutes. Yeah, as it ascends, the mixture of solutes starts dissolving. Some solutes are strongly absorbed by the paper, and so the ascending solvent finds it difficult to dissolve them. However, eventually they become dissolved, and when that happens, they are now carried up. and as they are carried up, they become absorbed by the next portion of the paper. This process of absorption and dissolution is continuously repeated on the solutes travel up the paper slowly. It's repeatedly done. Solutes which are weakly absorbed by the paper are easily redissolved by the ascending solvent. Such solutes, they quickly travel up the paper strip. In addition, solutes which are very soluble in the solvent move up at a faster rate than those which are not soluble. Thus, we see that the rate at which each solute moves up the paper depends on how strongly it is absorbed by the paper. It depends on its solubility. Those which are easily absorbed move up faster than those that are not that easily absorbed. Okay, so chromatography has two phases. The first stage is the stationary phase, on which the solutes are absorbed, and then the second phase is the moving phase, which dissolves the solute as they are carried up. Okay, so in the above example, the paper is the stationary phase while the solvent is the moving phase. Now, although paper chromatography is the most commonly used technique, however, gas chromatography, which is another method of chromatography, is important in industries, biomedical analysis and research, because it is an extremely sensitive technique. It's very sensitive. That's why it's important in this research, biomedical analysis and research. In gas chromatography, the stationary phase is a liquid mixed with solid, packed into a long glass column. Liquid mixed with solid packed into a long glass column, hence its name, glass chromatography. Into a long glass column with a small diameter. The moving phase is a fairly inert gas like nitrogen or helium. The moving phase, a fairly inert gas like, hence the name gas, not glass, gas chromatography. The moving phase is a fairly inert gas like nitrogen or helium and referred to as a carrier gas. The mixture to be separated may be solid, liquid, or gas. It is mixed with the carrier gas and heated to vaporize it where necessary and passed through the column when separation now occurs. So chromatography is used extensively in scientific research to analyze and identify substances. In the petroleum industry, chromatography is used for identifying the various constituents of the fractions obtained from the distillation of crude oil. In hospitals, this method is used to determine the presence of certain substances in the blood and urine of patients in order to help doctors in their diagnosis. Health departments use chromatography to check that food products do not contain more than the maximum legal amount of preservatives. In addition, they also use this method to check the constituents of chemical products. So this ends the separation of mixtures. This ends the separation of mixtures. However, we can just add a little more topic, just a little addition to this separation of mixtures, because they must go together. Purification of substances. So, you know, what is an impure substance? It is a substance, it's a mixture. An impure substance is a mixture, and impurities can be removed by using the appropriate separation techniques. That's why I say these impure substances must go with separation techniques, because a mixture that is impure must be separated by must be separated in order to make it pure. So how do you test for impurity? Sorry, how do you test for purity? And since once you have obtained a pure sample of the substance, you can now use the following criteria to determine its purity. The first is the melting or boiling point of a given pure substance is fixed at a certain temperature. So the boiling or melting point is fixed of any certain pure substance is fixed at a certain temperature. So you can use the boiling point or the melting point to determine the purity. Once there's an impurity there, it will not, the boiling point will be different and the melting point will be different. So the impurities affect the melting and the boiling point. Also, a pure substance gives one spot on a paper chromatography. It is used to check the purity of colored substances like dyes and pigments. So if it does not give that particular spot, then you know it is an impure substance. So this ends mixtures. This ends the topic on mixtures, and I will help you by listing some questions on the description and page, so you can test yourself to know how far you were able to grasp what I taught under these mixtures, or what I have taught so far from the first day of the lesson till now. And I would say this is the first quarter of the lesson. Well, call it first quarter, though I still have so many topics to finish to teach before rounding up the chemistry. There's still so many topics in chemistry. So just for you to know the topic you want, and then you choose. So I'll list the questions and then you answer. So thanks so much for watching. Don't forget to subscribe if you haven't done so, and hit the comment section, hit the like button and then I would appreciate your comment. So till next lesson, have a great day. Bye.